Okay. It's officially 10 o'clock, so it's time to start. My name is Andreas Hallberg, as you've probably seen, and this session is called the Jurassic Web Attack, as you've also probably seen. I work at TrueSec here in Malmö, where I spend my time developing security critical systems and also auditing, reviewing systems, and also some penetration testing. So I'm very glad that you all came here today to watch this. So before I get started though, there's just one quick thing I have to do. I apologize, I should have done this before the session, but I was out of time. The thing is, I was supposed to get some money here from Øredev. I just want to check that I have received that. Otherwise, I might have to cancel this talk a little early. Just log in. Oh, that looks good. Can you see those? Maybe I have to zoom in a little bit, right? How do I? Oops, no, that's not it. Yeah. Yeah, I have some transactions there. Can you see that in the back? Is it okay? Okay, cool. Good, yeah, I got some money yesterday, right? From Øredev to me through transactions. Awesome, so okay, we're good, we can go. Now I don't have to worry about that anymore. And, well, you don't mind if I check my email, do you? Also, I just quickly need to see here. Oh, look at that, I got an email from Stefan Ivarsson. That's a colleague of mine, actually. Let's see what he has to say here. See, I'm just gonna, yeah, you can see it. So, he wants me to click on this. What's this? Funny stuff? Yeah, that sounds cool. Maybe it's not safe for work, although this is not technically work, of course. So I'm just going to go ahead and click on that. Let me see what this is. Hey, look at that. It's the gladiator bird, all right. That's Russell Crowe merged with a some kind of rooster. Awesome. Oh, well, okay. Let's just see here if... Oh, no. What happened here? There's a new transaction from me to Evil Corp in the amount of $9.99, and it happened just now. Uh-oh. Does that have something to do with the link I clicked on, maybe? Let's try that again. Okay, there's Mr. Gladiator one more time. The same one. Okay, what's going on here? Let's examine that funny stuff page a little bit, shall we? Let's look at the source code of this. View page source. I have to zoom in here. Yeah, you can see that. So it looks good, does it? Here's the image, the gladiator bird. But what's this? A hidden iframe with heights, width 0 and height 0 of some page called post.html. Let's take a look at that one. Oh, this doesn't look good. This page is called Evil Web. You know that's not good. And it has a form that posts something to. This is the URL of my bank, actually. My bank is at localhost. It's very convenient. It's always up. So it has some hidden fields from to exactly the ones we saw, from me to Evil Corp with 999. And this form is automatically submitted as soon as the page is loaded by JavaScript clicking on the submit button. Okay. Let's take a look at this. How can that work? Because this is trying to do a transaction, right, against my bank, but this page isn't logged in. I'm logged in here, but this one isn't logged in. Let's look at the network traffic here, shall we? See what's going on here. I'm just going to reload this. I don't care that there's another transaction. Let me just zoom in here. So okay, we got the page, we got the gladiator bird that we expected, and then yeah, this evil page got loaded, post.html. And then there's this post, and it seems to have succeeded. That's a redirect right there, 302. So it tries to load another page called transactions, like the index page, I assume. So let's take a look at this call that went out from the evil page to my bank. So yeah, that goes to my bank, and let's look at the cookies here. Okay, here's a bunch of cookies. Let's take a look at that one, ASP.NET application cookie. That's the logged in, that's the login cookie I got from my bank. So what's happening, right, is that when I make a request to my bank, even though I didn't do it, the browser obediently sends the cookies along with it. So that's my authentication cookie. And from the perspective of my bank, everything is fine. So the transaction happens. Okay. So what happened? Okay, yeah, here's a quick run through one more time. Post, the able page did a post to transactions create with my authentication cookie that came from me being logged into my bank. So from the perspective of my bank, everything is fine. I'll just go ahead and do the transfer. So this is, of course, what's called Cross Site Request Forgery. That's what this session is going to be about. Cross Site Request Forgery is abbreviated CSRF, or sometimes XSRF, that's hard to say. Pronounced CSRF sometimes. And I'm not going to say CSRF because I've said it and my colleagues are making fun of me all the time for saying CSRF. So I'm going to say CSRF, just going to try to do that. So cross-site, or what does that come from? Well, of course, the content that was loaded from funny stuff, that domain got posted to localhost, that cross-site, different sites. Request forgery, well, it's pretty obvious. I didn't make this request. Some attacker that studied my bank and was able to craft a fake request, a forged request. So that's the request forgery in it. Cross-site request forgery. Let's take briefly a look at the history of CSRF. Here's an article from quite recently about banking Trojans in Brazil. It's not about CSRF. I'm going to say CSRF. It's so much easier. You can mock me all you want, okay? So I show this because maybe you can read this. It says here that it's a big problem with banking Trojans in Brazil, and the reason why it's such a problem is because for decades Brazil's banks have been on the forefront of online financing, pioneering electric systems, yada, yada, yada. So legend has it, now I don't have any good source for this, but that the CSRF attacks were seen in the wild as early as mid-90s in Brazil, because the banks went online and the ambitious hackers of Brazil soon figured out that you could create forged requests like this and have people click on links and whatever, and the authentication, of course, was not two-factor back in those days. Well, if you're logged in, it doesn't matter. They were logged in and the transactions happened pretty much like I showed you in the example. So it didn't have a name in 1995. The name Cross Site Request Forgery was coined by a fellow named Peter Watkins on a bug track mailing list in 2001. And he also gave a suggestion for the pronunciation there, as you can see. He talked about the problem of having image tags embedded on forums. Because what an image tag does, the source property, it makes a GET request to the server to fetch the image. So instead, if you change that source to like localhost transactions create, and if my site was configured to do the transaction on a GET request, this would have the same effect that I just showed you. So on the forum, you would just see a broken image, which is something you wouldn't react over, just like you saw the gladiator bird and thought that was funny and wouldn't see that something was going on in the background. All right, fast forward to 2015. Here's a vulnerability report from Red Hat's JBoss Enterprise Application Platform. How many in here are Java programmers? Hands up. And C#, .NET? Okay, so it's more Java than .NET, all right. Anyway, this is JBoss is the enterprise application. It's a server that you use to run your Java web applications in, basically. So here was a cross-site request forgery just recently, and it seems like the attacker could upload a file using this. So you could actually post a whole binary file up there. So I haven't investigated this further, but let's just hope that they protected the file afterward, that you can just access it from anywhere, because then you could upload a shell or whatever and use it. So here's the deal, right? So we saw that cross-site request forgery emerged in the mid-90s. Now it's almost some 20 years later, and it's still here. The thing is, when we do penetration tests and security reviews at TrueSec, we almost always see this, cross-site request forgery vulnerability in web applications. Although a lot of frameworks, all of them have protection against it. And sometimes I think when I talk to developers, people say that, well, there's no point in me protecting my application, really, because if someone wants to get in, they'll get in eventually, so why should I bother? Well, it's not entirely true. Because, sure, if that someone is a resourceful, skilled, professional, maybe even state-sponsored organization, yes, they will get in eventually. You'd better have your computer air-gapped. That's probably the solution. But the thing is, your application is not the target of a state-sponsored organization. Your application is the target of thousands of semi-skilled criminals and script kiddies, which just bombard your application with these trivial attacks like CSRF, I said it again, Cross Site Request Forgery, I said, I meant cross-site scripting, SQL injection, command injection, all those things. So the thing is, they don't have the big guns. They don't need to have the big guns. They're not sitting on 0 days that they can exploit your computer with. They just use these basic flaws that you can protect yourself against. So the good thing about this is that, sort of like the Swedish fictitious national hero Sven Duva, who held the bridge against the Russian attackers, so can you in your web applications. Of course, all the similarities between this and internet warfare is, of course, purely coincidental. I'm not saying that the hackers are necessarily Russians, but yeah. So you shouldn't, it's really the 80-20 rule, right? With 20% effort, you get 80% done. It surely applies to security very much. And cross-site request forgery protection is definitely within those 80%. So it's basic security hygiene. So without further ado, let's look at how you can protect your application. There's a fancy name for the golden standard, the gold standard for CSRF protection. It's called the synchronizer token pattern. We're going to look at it and we're going to see how to implement this. Before we jump into Visual Studio, let's just look at this word here a little bit. This is from Wikipedia. Token, an object which represents the right to perform some operation. And you can see here, yes, the laser pointer works. You have a security token, access token. It sounds pretty good. Sounds like something we want to use. An object which represents the right to perform some operation. Now, when we logged in at my bank, we got an authentication token. That's the cookie we presented to authenticate us at the service. We didn't have to write the username and password every time. And this, for CSRF protection, we did another token to convince our application that we do indeed have the right to perform this request that is being done. So let's go ahead and dive into some coding right away. So, yes, okay, I'm going to turn this off. Here's my persistence layer. Yeah, it's a text file. That's how banks do it, by the way, so you shouldn't be alarmed. So I'm just going to break here. How many are familiar with MVC, Model View Controller applications? So, okay, that's basically everyone. So this is a controller. It has some actions in it. It has 2 actions. No, sorry, 3 actions. This one lists my transaction. This one creates a form which I can use to create a new transaction. You haven't seen that yet, but you saw the result of this one. When you post the data back, it saves the transaction, and then it lists the transaction again. So, and you can also see that in order to use these actions here, you need to be logged in. This is what this attribute does, the authorize attribute. It makes sure you're authenticated. That's a strange name, but it's called authorize because you can add roles to it. So okay, we need a token to protect ourselves against cross-site request forgery. So the problem is, when do we issue this token? A login token is issued to the user when the user presents the correct username and password. So what is it that the user does that the attacker doesn't? Well, the user requests the form first, fills in the fields, and then posts the form. So we should issue the token when the user requests the form. We should give the token to the user, and then the user posts back the data, and we will check that the token is the expected token. So let's go ahead and look at that. So here's a little bit of code to create the token. Let me just make that a little bit larger, shall we? Like that. Okay, so we create a random string, just any random string. We save it in our session, and then we put it on the view. And why do we save it in the session? Well, we need to be able to validate it when the token comes back from the user. So we need to save it, and we also need to include it in our view here. So I'm just gonna do a little something here. Put a field in here, which will render, will create a hidden input field called CSRF token, and we pick out the token that we just put in there. So that's half of it done, but the most important part, of course, is not done yet, the actual validation of this. We need to check that we got the token we expected. So, like this. Actually, we don't really need to do that. So, when we get the data back, we look in our session for the CSRF token object. If there's no such thing, if it's null, we just set it to empty, string empty. And then we also need to get the token from the form. I need to pick it up from model binding here, like that. So ASP.NET will do that automatically for us. Let me just make sure you can see this, like that. So, and if the token that we stored in our session when we issued it does not match the token coming in from the user, we return forbidden here. There's also another, this method is something I wrote myself, which is not in the framework. It means that you do a time constant comparison. If you just do equals on two strings, it will terminate quicker if the strings don't match, depending on which character. It does a sequential search of the characters. That can be used as a side channel timing attack. So I just wanted to protect myself against that. That's a little bit of extra credit, but I'm just going to thank you, Sebastian, for pointing that out. It's very good when I did this before. So okay, let's just run this. Start my bank again. Here, and let's close these old tabs so I don't mess something up. And let's just set a breakpoint here, right here. And then, okay, yeah, here we see now we create a transaction the legal way. Here's the form. Let's look at the source code. There we go. I'm just going to do like that. Scroll down. Here it is. Here's the input field, CSRF token, and this random string that we just created. And it starts with FIYS, right? FIYS. So let's do from me to all of you, 100 kroners each. Congratulations. So we break here. Let me collapse that. Let's see here. CSRF token in session. Oh, you can't see that. It's really tiny, but it's the one we just put there, of course. And the one coming in is equal to that one. So if we step through here, we're good. Everything works. But now if we are the attacker instead, we click on our link again. Okay, we get in here. We will now have a token in session actually. It's the old token, the one we just had. But the one coming in is null because the attacker could not include a token on his form. He didn't know the secret token. So this check here will fail and we'll get a forbidden response back, which won't be seen here unless we do look at the network traffic here. So just reload that, and then we got a breakpoint again. Oh, sorry, let me do that. There we go, and go, and here. So if you look closely here, you see that there's, say, 403 right here. So okay, we have protection against this attack. Awesome. That's the synchronizer token at its most basic level. That's not basic. I mean, it's a basic protection, but it works. This is the way to do it. I'm just going to show you a little bit of a variant of this. Sometimes you see frameworks using cookies instead. But what we're doing here, we're putting stuff in our session. So we're using state on the server. And for some people, that might be a problem, saying, oh, we can't have state on our server. We're using too much memory. I don't think so. Maybe if you have a huge token. But what do we do instead? Of course, we can send the state to the client instead. We'll let the client take the burden of the state. So we'll just do this response. We'll put in a cookie instead. Response set cookie, new HTTP cookie. And we'll just do this same one. It's called the same thing, and we'll just use the random string there again. Whoops. And there. And then, of course, we have to remember to instead pick it out of the cookies instead. This request this time, right? Cookies. And we get this cookie out. And we need to do value right there. So that's also something you see in the frameworks. Instead of saving it in the session, you put one cookie and one in the form, and then you compare them when the request comes in. That works fine. Now, of course, this ASP.NET has this protection built in for you to use. Let's remove this and show you how you're supposed to do it by using the framework. This that I just did, that compares the cookie with the one in the form, is called, all that code is done by using the validate anti-forgery token attribute. And to create and issue the token to the form, we'll just, there's a HTML helper for this, and it's called conveniently anti-forgery token, like this. So that's there in the framework already to help you. Actually, this does a lot more than what I just did. It doesn't create a random string. It actually encrypts your username with some other stuff with a machine key, and then the validate attribute decrypts that. So actually, the cookie is not needed. The cookie is for another use case. It has to do with login CSRF, which I'm going to talk about later. So it's actually stateless because it can it encrypts your information in the token, then decrypts it. But we don't have to become that fancy in our example there. So, okay. We issue the token on the GET request in the form. But what's, of course, as an attacker, you would just say, okay, that's fine. I'll just do a GET request first, right? And then read the result back, get the cookie from the set cookie header, get the token from the form, just read it out with some JavaScript DOM manipulation, and then insert the cookie and the token in my request going back in the post request, and I should be able to bypass this defense. Well, let's go ahead and do that. So let's make sure we're going to run the bank again here. But it's running, and I have a page prepared for you here. So this one. Yeah, this one is called post 2. What I'm doing here, I'm creating an XML HTTP request. That's the way of doing a JavaScript, HTTP request from JavaScript. And I do the open to my transactions create with a GET request to be able to get the form and the token and pick it out of it. And I haven't really implemented it yet, so I'm just, for debugging purposes, I'm just going to do a few pop-ups to see that I get the cookie and that I get the response, that I can look at the form and everything. So is my bank up and running? Yes, it is. So I'm just going to browse directly, since I know that this is called post 2. Okay. So, sorry, let me just do this. Do you see that? Yeah, we get, it's really bad. So set cookie, the set cookie header is null when I try to read it. And the response text is empty, and this, of course, is just from Firefox wanting me to see if this page is popping up a lot of dialogues that I maybe don't want. So what's going on here? Isn't this request working? Let's put a breakpoint here in the controller. See that we actually get in here. Let's reload this page. Okay, we're hitting the breakpoint, so the request is going out to the server. That's weird. Let's look at the traffic here again. And reload. Let's see if this... Okay, we hit the breakpoint again. And network. And we get the create action. We get a 200 back. Everything seems fine. Let's click on that. But here, the response back is empty. We can't see anything here. That's weird. So the server responded correctly with the form, but when we look at it in the browser, there's nothing here. So what's going on? Okay, let's examine this. So we try to do a, so this is a normal case, right, of the synchronized token pattern. You do a GET, you get the token back, and you include it in every request back to it. That works fine. Everything's good. So what we try to do here in post 2, the evil page, okay, we do a GET first. We get the result back. Everything's fine. We can examine the cookie and the token. But something happened here. What's going on? We're not able to read here. We can't read. The response text is empty, and the set cookie header was null. So something is stopping us from reading this. So that's why this protection works, right? I just show you. So in order to understand this, we have to go back in time to 1995 again and talk about this browser. How many has used this browser? Do you remember? Yes, all right. This is Netscape Navigator 2, released during the first browser war between Microsoft and Netscape in 1995. Introduced a bunch of features that we take for granted / are stuck with today. They introduced the DOM, Document Object Model, and JavaScript. And the inventor of JavaScript is this guy, Brendan Eich. He works at Mozilla right now. Here's an article from New York Times from 1996. Where he was 35 years old, so that would mean he's 55, sort of, in that picture. And it talks about how he invented JavaScript in a little more than a week. Actually, I think the official now it's 10 days that he invented JavaScript. And also pretty funny here that the purpose of JavaScript is to give potentially millions of people who are not programmers the ability to use this. So there's a joke in here. I'm not going to say it. So JavaScript being very popular. Sorry? Exactly. That's the joke. I didn't say it. No, of course not. Well, another funny thing, JavaScript wasn't called JavaScript first. It was called LiveScript. But they renamed it, rebranded it to JavaScript because Java was like the coolest thing in the browser, the Java applets. So everybody wanted to be associated with Java in the browser. So not so much anymore, right? So the good thing about this that they didn't just invent JavaScript and the DOM, but they also made rules on how JavaScript can interact with the DOM. And this is called the same origin policy. The same origin policy is the cornerstone of the browser security model, truly. It's a super important concept, and with such an important concept, you think that there was a specification, an RFC, somewhere that you can read and just read and understand all about it. There isn't. There's no spec. This is just a bunch of rules, a de facto standard that's used by well-behaved browsers. And a good formulation of this I found in a good book called The Tangled Web, which I'll mention later also. Given any two separate JavaScript execution contexts, one should be able to access the DOM of the other only if the protocols, DNS name, and port numbers associated with their host documents match exactly. All other cross-document JavaScript DOM access should fail. So now we know what happened, right? We did a get, got a 200 back, stop. Why? Well, because funny stuff is not equal to localhost. This is a cross-domain access. Here, the content that was loaded from funny stuff, the JavaScript that was loaded from funny stuff, tried to access the DOM of an object, of a page that was loaded from localhost. Same origin policy kicks in and throws us out. This also applies to the headers. The sentence I just read to you was about JavaScript and the DOM. It also applies to the cookies, sorry, not headers, the cookies. Cookies were invented 1 year before JavaScript in 1994. So when JavaScript came along and said, oh, it's probably not a good idea if the JavaScript can read the cookies, since cookies are used for authentication. So if you have JavaScript from one domain, then it could read the authentication cookie from another domain and just be logged in. So same origin policy applies to that too as well. So while we're talking about cookies, there's another variation of the synchronizer token pattern called the cookie to header token, which is useful and used by JavaScript frameworks like Django and AngularJS. When you're programming in JavaScript, it's inconvenient to do form requests and responses all the time. You basically have one page and you do requests back all the time dynamically from the JavaScript. So the cookie to header token pattern works like this. Here's good.com doing its first initial request to load the page. Then you get a CSRF token back in a header, a cookie, sorry. So you'll set the cookie for the duration of the session, and then every time the JavaScript does a post, it includes this token as a header instead, which then the server can validate just like we did in our example. So that's really convenient for JavaScript frameworks and used in Django and AngularJS. So the reason now, why doesn't this work? Why can't we issue this request? Well, of course, when evil.com tries to get at the cookies, well, evil.com is not good.com, so you can't read the cookies, so that protection works also. There are other options that does not use a token that I think I have to mention also. There's a header called the referrer header, and referrer, by the way, is spelled like this. It's a misspelling that was done in the RFC for the referrer header for HTTP, and we're stuck with that. It's supposed to be 2 R's in the middle there. So the referrer header, when you send away a request, the referrer header includes the page you were at before. The problem with this, though, is that if you're on an HTTPS page and you navigate to an HTTP page, the referrer header is removed. And also, of course, a non-negligible part of the population strips the referrer header for privacy reasons, because the referrer header, of course, tells the server where you've been before. So it doesn't work that well for CSRF protection. Of course, the way you would read the header and see that you came from the expected domain. That would be the protection, right, for this. There's another trick you can do with headers. there is a restriction on cross-domain headers. JavaScript from one domain cannot just create a random header in a post to another domain. So the thing with this is, though, is that it has been broken by Flash, notably, in the past. Flash would allow you to include a custom header, which would then fool the CSRF protection. And this is not really same origin policy per se. It's a restriction that is a little bit weaker. But it works, but it's not as good as the synchronizer token pattern, if you want to use that. There's a header called the origin header, which is quite new. It's this side of the millennium, at least. It was supposed to be used for explicit CSRF protection instead of the referrer header. But of course, the same problem happened to that one, that people started stripping out the origin header for privacy reasons. So it's not really reliable to rely on that. And it ended up as sort of a limbo. Not all browsers support it. Notably, Firefox does not just include the origin header on all requests. The origin header, though, it got a new life in something called cross-origin resource sharing. How many have heard about this? Okay, not that many. Cross-origin resource sharing is not a protection against CSRF. It's a way to relax the same origin policy. If you have two domains that you know that they should be able to communicate with each other, you can instruct the server to return some headers that will let the browser know that, yes, in fact, it's okay that JavaScript does a cross-domain request and reads back the result from this domain, because, well, the server tells me that it's okay. So it's very useful, but of course, when you tell the browser which domains are okay to access your resource, you can do a star like right there, and then, of course, every domain, any domain can do JavaScript requests to your cross-site request to your domain, and then you've turned off the same origin principle there, same origin policy. So you shouldn't do that. That's something you typically do in development, right? Because you don't know what the origins will be when you go into production. And then for some reason, it always ends up in production anyway, even though you didn't expect it to. Okay, so we've talked a lot about Cross Site Request Forgery, obviously, the history of it. We've seen the synchronizer token pattern, how to implement it, and of course it's there in most frameworks for you to use. Same origin policy, some tokenless options. Before we end this, we're just going to look at some flavors of CSRF called login CSRF. So the thing with Cross Site Request Forgery that we've seen, what it does is that it exploits the fact that you are logged into another page and uses that to perform some action as you, because your cookie goes long, so the server can't differentiate between this forged request and a regular request. Login CSRF, on the other hand, logs you in somewhere and does something does something on your computer while you're logged in as someone else. So, or your computer or something else, logged in as someone else. So what's the point of this? Okay, here's an article from Brazil again. The thing is, router, your home router, problems that they had in Brazil was that the routers came with hard-coded admin credentials. That was really easy to figure out. And compound with this with the fact that your router is usually found on the same IP address on your home network. Right? It's like 192.168.0.1 and some port number. That's well known by everyone. So if you crafted your forged request, not going to like transact my bank, localhost, whatever, but to this IP address, and you could include your credentials in the query string, and then you can get this router, log into the admin interface, and reconfigure your router. And what the attackers did was that they reconfigured the address of the DNS server that's coded inside the routers, so that when you visited your bank, it would instead reroute you to the attacker's computer, and he could then harvest your username and passwords and a bunch of stuff like that. So here's another one, more recent, Brazil again, same thing, hard-coded passwords. So what's going on in Brazil anyway? But yeah, before we laugh too much about that, things aren't exactly peaches here on the home front either. This is about Bredbandsbolaget, the Swedish company, who also had hard-coded password in their router. So the exact same attack could be done here. I think the username was Kung, actually. It means king in Swedish. So, yeah. And the other thing about this is that it can also be used, logging CSRF can be used to monitor your activity. Maybe you don't notice if you're logged into YouTube. Like if you click on a link and someone logs you into YouTube in their account, they can monitor your activity. So they can see, of course, all your Justin Bieber watching videos and use that to blackmail you. So that's the other thing. And of course, you can use this on any site on the internet that you're logged into that you don't want people to know what you're doing there. This can be a target of this. And if it's not obvious when you're surfing on the web that you're logged in as someone else, then that someone else is sitting and just reloading the same page and seeing everything you do. Okay, we're about ready to wrap up. There are 4 things that I want you to take home with you from this presentation. Synchronize the token pattern, of course. Gold standard of CSRF protection. It's there in every framework. If it's not there, you can do it yourself really easily, like I just showed you. Same origin policy. This thing just seems to be getting your way the whole time. Enjoy it. It's there to protect you. Without it, you know, we'd all be out of a job probably. There wouldn't be an internet as we know it today. And you're not the target of the NSA or any state-sponsored organization. Your application is the target of thousands of semi-skilled script kiddies that just use these basic tricks to hack your application. That's how they gain foothold to the system, not by using 0 days and anything like that. So protect your application against this. It's basic security hygiene. It's simple. It's easy to do. And I just want to finish with recommending this book. It's really good. It's called The Tangled Web, written by Michal Zalewski from Google. It's the book version of the Google's Browser Security Handbook, which is available free online. It's really good, covers this and everything in excruciating detail that you need to know about the web, why it works the way it does today, what the security features are, and just a really good book. You should really look it up. Okay, that's it for me. If you want to contact me, you can tweet me or email me. Don't be shy. If you have any questions, we can take them now. We have 3 minutes for questions. So, anyone? Yes, in the back. The question is, how do you protect your site from use in an iframe? Well, there's a header. When I did this demo, I couldn't get it to work if I didn't include a special header from the evil page. The evil page must tell the browser that it's okay that I am included in an iframe. So by default, your site should not be able to be included in an iframe like that. So you have to explicitly allow it. So that's good. But of course, a lot of sites do that because they want to be included in iframes for regular purposes. So. Yes? No. How would you stop people from putting invisible iframes on their pages? I'm sorry? I know there are some browsers are better at detecting this than others. I think Chrome has some sort of protection. I don't know. It has to be a browser feature that somehow detects. Or you can use, there are plugins like NoScript, which is really good, which detects these clickjacking attempts as well. So it's not usually a built-in feature, but there are ways. And there are a lot of false positives, of course. They say, oh, it's a clickjacking attempt. No, it's not. It's just the site looks like this. I get it from Sydsvenskan, our newspaper here, always, the NoScript alerts me that, oh, there's a clickjacking attempt going on, but there's just something that they're doing that gives this false positive. So, okay, I'm going to be here all day, so if you need to ask something, just grab me out there. So, okay, thank you very much. Thank you.